Imagine holding a simple, fragile egg in your hand, and then imagining it being dropped, not from a rooftop, not from an airplane, but from the edge of space itself, over 100 kilometers above the Earth's surface, where the sky turns black, the air is nearly non-existent, and temperatures swing from searing heat to bone-chilling cold. Sounds impossible, right? What would happen if you dropped an egg from space? Would it burn up instantly? Explode from pressure? Or could it, against all odds, survive the journey to Earth? In today's video, we not just cracking a shell, we cracking open a cosmic mystery that mixes physics, engineering, and the sheer insanity of human curiosity. First, let's think about the vacuum of space. At that altitude known as the Kármán line, there's practically no air, which means no atmospheric pressure and no drag. If you simply let go of an egg at this height, it wouldn't immediately fall like a rock. It would float, suspended, traveling at the same speed as the spacecraft or high-altitude balloon that carried it up. But let's assume we find a way to give it a gentle nudge downward. What happens next is a breathtaking journey. For the first few kilometers, the egg would drift in microgravity almost like a tiny spacecraft, till it enters the upper layers of the atmosphere. That's when the real chaos begins. As it starts to fall faster and faster, Earth's gravity pulls it into a deadly dive, and it begins slamming into molecules of air at hypersonic speeds. This is the phase where meteors burn up, and it says the part most people assume would destroy the egg instantly. But here's the twist. The egg itself wouldn't necessarily burn, because unlike a meteor, it doesn't start its descent at several kilometers per second. It's not going fast enough to generate the friction needed for full incineration. Instead, the egg would accelerate gradually, picking up speed as it falls. However, the next big enemy isn't heat, it's G-force. As the egg plummets, it experiences increasing gravitational stress. And the shell, already weak by nature, is unlikely to withstand the violent vibrations and air turbulence. But let's get creative. What if we encase the egg in a heat-resistant, shock-absorbing capsule? Engineers have done similar things before. In fact, students and scientists around the world have competed in egg drop experiments, using everything from foam balloons to 3D printed capsules to protect eggs from high drops. Scaling that up to a space-level egg drop means designing a miniature reentry capsule, much like NASA's return vehicles, complete with ablative shielding, parachutes, and possibly even gyroscopic stabilization to keep the egg from rotating too violently. Now, let's go further. Suppose we perfect this capsule and launch it on a high-altitude balloon, like those used in near-space missions. At 35,000 meters, the sky is pitch black, Earth curves visibly, and conditions mimic outer space. From here, we release the egg capsule. Cameras capture the moment. It's a dramatic free fall through layers of Earth's atmosphere. First, the thin upper air offers little resistance. Then comes the denser middle layer, where heat builds up. And then finally, the troposphere, where weather happens and parachutes deploy. If timed right, the parachute slows the capsule gently enough to allow it to land on the ground intact. If our design is good, the egg survives. If not, it's scrambled across the landing zone. But here's what makes this even more fascinating. In 2012, a man named Felix Baumgartner jumped from a balloon in the stratosphere, over 39 kilometers above Earth, breaking the sound barrier with his body. If a human can survive a fall from near space with the right suit and parachutes, then surely a humble egg with the right tech has a chance. And yes, this has been tested in various forms. Some universities have already conducted egg drops from the stratosphere with surprisingly successful results. But no one has yet dropped an egg directly from orbital space 400 kilometers above Earth, like where the International Space Station orbits. That, my friends, would be the ultimate test. Not only would it need a heat shield to survive re-entry speeds of over 17,000 miles per hour, but the egg would also need to endure several minutes of extreme G-forces, friction, and searing plasma. Could it be done? Theoretically, yes, but it would take a capsule just as advanced as those used in human spaceflight, scaled down to protect something that cracks under your fingertip. The bigger question here isn't just whether the egg survives, but what this kind of experiment teaches us. It's about understanding re-entry physics, learning how to engineer for survival in extreme conditions, and exploring just how fragile or resilient nature can be when paired with human ingenuity. A simple egg becomes a symbol, a metaphor for exploration, fragility, and triumph. It asks a deep question. What happens when we take something ordinary and subject it to the extraordinary? So the next time you see an egg, don't just think breakfast, think space, science, and the incredible journey that could begin with a single drop from the stars.